When working with fractions, a lot of our time is used in simply changing the wholes to pieces, making improper fractions into mixed numbers, making equivalent fractions. When we have a whole, it's easy to understand. When we have 8/8 shown like this, it's kind of like, what does it all mean? How many are there? Maybe I miscounted. Here's a whole with fourths, and this is the jumbled up part. But let's face it, when you're making cookies and you take out the bag of flour, do you use the whole bag of flour or just a fractional part of it? When you're studying for your social studies test, you don't need to read the whole book, just the test is on that one chapter. That's a fractional part of the whole. So this is not a very foreign concept. You're used to thinking of things in the whole, and you're used to thinking in things in parts. If you say, I'd like to have a snack, but I can't eat the whole apple, so you would cut it and just eat a portion of it, a fractional portion. So as we continue using our fractions, you're going to see how a lot of what you do is putting together and breaking apart. Putting together for understanding, breaking apart for actual calculation. So let's see what one of these problems looks like with the pictures. Let's say our problem is 7/8 plus 3/4. Let me get my parts here. I have 1, 2, 3, 4, 5, 6, and 7/8. All right, we'll use that one for 7/8. 1, 2, 3, 4, 5, 6, 7/8. And we have 3/4. 1, 2, and 3. It's obvious that we cannot add the fourths to the eighths. They're not the same size piece. So the first thing we have to do is make common denominators. I'm going to set my paper up like this, so when I'm ready to think of the numbers, I know just where to put them. We need common denominators, so the larger pieces here have to be cut. What's in common with eighths and fourths? Well, let's take the bigger number, 8. Is there something we can do to 4 to make it 8? Is there something we can multiply by 4 to get an 8? Yes, you can multiply times 2. So if we multiply this fraction by 2, we will get our common denominators of 8. 2 times 4 is 8, so 2 times 3 is 6, and that's the equivalent fraction. 7/8 is already an eighth, so I'll just move it over. I can keep all of my pink slices, but the orange ones will have to get changed into eighths. So as you can see, I'm going to need 6 of these. 1, 2, move it down. 3, 4, 5, 5. Oh, that doesn't want to stay on either. Okay, we'll just put it here. 5 and 6. So I have 7/8 here, and I have 6/8, 1, 2, 3, 4, 5, 6, that I changed the fourths into eighths. Now everything is the same size piece. We can then do our math. The denominators are the same, so I'm going to drop my 8 into the answer. That's the denominator. And then add the top numbers, the numerators. 7 plus 6 is 13. This tells me that I have 13 of these eighths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Mathematically, pictorially. Now I say, okay, but I don't understand what that means. I know I have an improper fraction. The numerator is larger than my denominator. So I know that I can divide my 8 into the 13 because this is a top-heavy fraction. I have more pieces than a whole circle. So if I did the math on it, I would say 8 I know divides into 13 one whole time, but I'm going to have some pieces left over. So this uses up 8 of them. 9, 10, 11, 12, 13. I have 5 left over. So it's saying that I have 5 eighths left over. 1 and 5 eighths. These are equivalent fractions. I now have an improper fraction that changed into a mixed number. Let's see if we can get these to become the whole circle again. 1, 2, 3, 4, 5, 6, 7, 8. That gives me my one whole circle with 1, 2, 3, 4, 5 pieces left over. Do you see how this does not make a full circle? So I have one complete circle. This is 1. That's how I got my whole number. And 1, 2, 3, 4, 5 eighths of another.